Alright, now let's look at the topic of position vector. The meaning of position vector is the vector relative to the origin O, which is 0, 0. So let's look at the graph. So here we have a point D, which is 4, 3. So we can say the vector OD is 4i plus 3j. Now we can actually write vectors in many forms. So let's take a detour here. O passes through A, B, C, and lastly D. Right, so we can actually write OD again as OA plus AB and plus BC and lastly plus CD. And we can actually sum up the vector, and at the end it will be the same as 4i plus 3j. Let's look at this part. This part is very important for us to learn how to write vector in a fast manner. So we want to find vector AB. Usually we do not need a graph to solve this as long we have the coordinates, but the diagram is for you to understand better. So as we talk about just now, vectors can be written in many forms. So instead of going in this direction, we take a detour, A going back to the origin O, and then from O to B. Okay, so we can rewrite vector AB equals to AO plus OB, and we need to reverse the vector AO. So whenever we reverse the vector AO, it becomes the negative form. So it equals to negative OA plus OB. So we rearrange this, it will be OB minus OA. So this is a practice that is very important for us to write any vector in the form of position vector. So let's substitute the position vector, and we'll get 4i plus j. Now we want to use position vector to show that 3 points fall on a straight line and 3 points form a right angle. So in this example, we have 4 points with all the position vector given. To show that this example, line ABC is a straight line, we start by writing this line AB equals to lambda AC. So the difference with this and showing parallel lines is we start by writing AB equals to lambda AC. So now we write again using position vector, and we substitute the position vector to find the value of lambda. As long we can find the value of lambda, we can show that at the end ABC is a straight line. So the value of lambda is half, and we can conclude vector AB is half of AC. Now we want to show that ABD is a right angle. To show that ABD is a right angle, let's recall what we have learned from a straight line. We use the formula m1 m2 equals to -1. So as long we can show that the gradient of AB multiplied by the gradient of BD is -1, then ABD is a right angle. But before we find the gradient of AB and BD, we need to find the vector of AB and BD. So using position vector, we can find the vector for AB and BD. And now we are going to use this vector to find the gradient. Now the good thing about vector is the negative value here helps us to find the gradient. So in case there's a negative gradient, this will help us to get the negative gradient. So now gradient of AB multiplied by gradient of BD, we can show that at the end is -1. So we can conclude that ABD is a right angle.